Okay, so this is the sixth video in the series about fractions. Okay, so previously we did an introduction to fractions, simplifying fractions, converting between mixed numbers and improper fractions. We did equivalent fractions, comparing fractions. So for this one, we're going to multiply fractions and mixed numbers. Okay, so let me pull up my whiteboard. Okay, so multiplying fractions. Now, if you were reading in a textbook, they would generally show you something like A over B times C over D equals AC over BD. This is actually completely true, okay? So a lot of times books would say multiply across. And what they mean by that is multiply your numerators, multiply your denominators, and then it would tell you to simplify. This is true. However, when we multiply numbers, we end up making those numbers bigger, okay? And we already know from simplifying fractions that sometimes that can be a little bit difficult. So what I tell my students to do is first, cancel any common factors. Top versus bottom. So basically, simplify first. And then I tell them to multiply across. The reason for simplifying first is that you kind of take care of that simplifying when you're dealing with the smaller numbers. It makes the simplifying easier, and it also makes the multiplying easier. So if you're multiplying, somewhat large numbers to begin with, you may have to do some side work or use a calculator. Then you've got these huge numbers that you have to simplify. So simplify first by canceling any common factors. You see top versus bottom, anywhere in the top versus anywhere in the bottom, then multiply across. In many cases, you won't even have to use a calculator. All right, so let's look at a quick example first that doesn't require any simplifying, just so you can see kind of the process. Let's say I had 1/3 times 2/5. Well, if I look at the numerator, I've got factors of 1 and 2. If I look at the denominator, I've got factors of 3 and 5. None of those factors have anything in common. 2's don't go into 3's or 5's. 3's and 5's don't go into 2's. There's nothing that could cancel. So I just multiply my 1 and my 2. I multiply my 3 and my 5. And I get that the final answer is 2/15. And you can see that 2/15 is simplified. 2 has factors of 1 and 2. 2 doesn't go into 15. This is as good as it's going to get. All right. Now let's start looking at examples where we do need to simplify. Let's say that I had 10/18 and I wanted to multiply it by 9/5. Now, a lot of you can multiply 10 and 9 in your head and 18 and 5 in your head. Some of you can't, and you'd have to pull out a multiplication table, a calculator, or do some side work. But I encourage you not to multiply first, okay? Instead, look for common factors in the top and the bottom. What my eye is drawn to right off the bat is the 10 and the 5. I noticed that 5 and 10 have a common factor of 5. So for me, I want to divide the 10 and the 5 both by 5. Well, 5 goes into 10 twice. 5 goes into itself once. I also noticed that 18 and 9 have common factors. They have common factors of 3, but they also have common factors of 9. So I'm going to go ahead and divide both of these, 9 and 18, by 9. 18 divided by 9 is 2. 9 divided by 9 is 1. So then I come over here and I'm going to now multiply these little numbers. I get 2 times 1 is 2. 2 times 1 is 2. So what do I get? I really just get 1. All right. So let's try another example. Let's say I have 14 over 9 times 12 over 23. Okay, I always want to look to see if there's any kind of common factor in the numerator or the denominator. Okay, and I'm drawn to the 9 and the 12. I know that 9 and 12 both have a common factor of 3. So I'm going to divide 9 by 3. So 9 divided by 3 is 3. 12 divided by 3 is 4. And then I want to look to make sure there's nothing else in the numerator that could be canceled with anything in the denominator. So factors that are in the numerator would be 2s, 4s, or 7s or 14s. In the denominator, I've got factors of 3s and 23s. Nothing is in common. So I just want to multiply across. So I would get 14 times 4, 3 times 23. And if you need to do a little side work, do a little side work. There's nothing wrong with going out over here to the side and saying, okay, 4 times 14. Well, 4 times 4 is 16. Keep a 6, carry a 1. 4 times 1 is 4, plus 1 is 5. If you need to do the side work, do the side work. Same thing, if you don't know what 23 times 3 is, do the side work. 3 times 3 is 9. 3 times 2 is 6. So here we would get 56 over 69. All right, let's try one more on this screen. Let's say I have 25 ninths, and I want to multiply that by 3 over 100. Okay, so again, we could go ahead and multiply 25 times 3 and get 75. We could multiply 9 times 100 and get 900, but simplifying 75 over 900 might be a little difficult. So let's look for common factors now. So the first thing I'm drawn to is the 3 and the 9. I know that 3 and 9 have a common factor of 3. So I'm going to divide 3 by 3, I get 1. I'm going to divide 9 by 3, I get 3. I also notice that I have 25 and 100. Both are ending in either a 0 or a 5, so that tells me they're divisible by 5, but it turns out that 25 and 100 are actually both divisible by 25. So 25 divided by 25 is 1. 100 divided by 25 is 4. So now I can multiply across, and remember, we're multiplying these little numbers. All right, in fact, what we're really doing is we're multiplying 1/3 times 1/4 if we kind of clean things up. So multiplying across, I get 1 times 1 over 3 times 4. Simple as that. Let's try another one. Let's go to a new screen. What if I had 30 over 42 and I was multiplying that by 7 over 100? All right, again, you could go ahead and multiply 30 times 7, you'd get 210. You could multiply 42 times 100, you get 4,200, but that would be really difficult to simplify. So instead, simplify first. Now, when I look at the 30 and the 100, they both end in 0. And if you go back to a couple videos ago, we talked about divisibility rules. And if numbers end in 0, they are divisible by 10. So 30 divided by 10 is 3. 100 divided by 10 is 10. All right. Now, 7 and 42, I happen to remember that 7 times 6 is 42. So that tells me that 7 and 42 have a common factor. The common factor is 7. So I divide 7 by itself. I divide 42 by 7. I get that 6. And I'm going to clean this up just a little bit. So what we have now is 3 over 6 times 1 over 10. Do you see any additional factors that would cancel? I'm drawn automatically to 3 and 6. I know that 3 and 6 have a 3 in common. So 3 divided by 3 is 1. 6 divided by 3 is 2. And then finally, I get 1 times 1 over 2 times 10. So that's my final answer. All right. Let's keep working on examples. So let's say that I have 42 over 70, and I have 20 over 12. All right, there are several ways you could start by simplifying. Just keep in mind any factor anywhere in the top with any factor anywhere in the bottom. So I happen to notice that 42 and 70, we just had an example with 42 in the previous problem. 42 is divisible by 7. Well, 70 is also divisible by 7, right? So I'm going to take 42 and 70, and I'm going to divide them by 7. 42 divided by 7 is 6. 70 divided by 7 is 10. Okay? And I just want to keep going. 20 and 12, they have a common factor of 2, so we could go ahead and do that. You could divide the 20 and the 10. You could divide the 6 and the 12. Whatever makes you happy. If you feel like it's necessary, you can just kind of clean up the problem. I can change it to the first fraction is now 6/10 times 20/12. Sometimes that helps people just to clean it up. No matter what, keep simplifying. So let's say that we do the 6 and the 12. Well, 6 and 12 have a common factor of 6. 6 divided by 6 is 1. 12 divided by 6 is 2. And then the 10 and the 20 have a common factor of 10. They're both ending in 0, so we know it's divisible by 10. 10 divided by 10 is 1. 20 divided by 10 is 2. So I multiply across. I get 1 times 2 is 2. Well, let me do that in blue, be consistent. So 1 times 2 is 2. 1 times 2 is 2. This one simplifies simply to 1. All right. Let's keep trying. Let's say I have 18 over 42. There's that 42 again. Times 14 over 75. Now, it does not matter where you start. It doesn't matter which factors you cancel first. There are going to be some factors that are going to make the problem quicker. There are going to be some where you're going to have to do multiple steps. Doesn't matter. Just get simplifying. Okay. So for me, I noticed that 18 and 42 have a 6 in common. So I'm going to divide 18 and 42 by 6. 18 divided by 6 is 3. And 42 divided by 6 is 7. Now, if it's really important to you, you can clean this up a little bit. We can write this as 3/7 times 14 over 75. And then we can start simplifying again. For me, at this point, I'm very drawn to the 7 and the 14. I know 7 and 14 have a common factor of 7. So 7 divided by 7 is 1. 14 divided by 7 is 2. And then I also noticed the 3 and the 75. 75 and 3 have a 3 in common. 3 divided by 3 is 1. 75 divided by 3 is 25. So now I have no other common factors. 2 and 25 have nothing in common. So I multiply across. I get 1 times 2 all over 1 times 25. All right. So again, it doesn't matter where you start with your simplifying, just start simplifying. We could, several of us could try this problem different ways and get the same answer, but we maybe go about it in different steps as far as our simplifying. Just put the pencil to the paper and try something. All right. Let's try maybe this one. So this one's going to be a little bit different in the fact that it has 3 fractions that we're multiplying. Doesn't really change anything. It just adds kind of an extra layer to the problem. But let's say that we have 5/9 times 12/20 times 16/8. So again, we could approach this problem in different ways. At the end of the day, we would get the same product, but just start simplifying. For me, I'm automatically drawn to the 5 and the 20. Okay, I know that 5 goes into itself once, and it goes into 24 times. All right, I am also drawn to the 16 and the 8. I know that 16 and 8 have an 8 in common. So 8 goes into itself once, into 16 twice. I could also look at the 9 and the 12 or the 12 and the 4. I'm going to go with 9 and 12. I know that 9 and 12 have a 3 in common. 9 divided by 3 is 3. 12 divided by 3 is 4. So what I'm going to do now is I'm just going to clean the problem up. It's getting a little messy. So what I have now is 1/3 times 4/4 times 2 over 1. Let me make that a little bigger. It's kind of getting hidden in the first part of the problem. All right, so I have 1/3 times 4/4 times 2 over 1. You can do some simplifying here. I see right away I've got 4 over 4. And let's go back to the previous video. What did we decide that 4 over 4 is really equal to? If you remember, 4 divided by 4 is really just equal to 1, right? So what I really have is 1/3 times just plain old 1 times 2 over 1. All right. And remember, when you multiply by 1, nothing really happens. So 1/3 times 1 is really just 1/3. So I really get 1/3 times 2 over 1, which is 2/3. All right. Let's do maybe 2 more like this where we have the 3 fractions instead of 2, and then we'll start talking about how to multiply mixed numbers. All right. So let's say that we have 15 over 18 times 16 over 21 times 28 over 25. Now, you can start anywhere, doesn't matter, okay? I'm automatically drawn to the 15 and the 25. I know that 15 and 25 are divisible by 5. So 15 divided by 5 is 3. 25 divided by 5 is 5. I'm also drawn to the 21 and the 28. For me, I see automatically that 21 and 28 are divisible by 7. So 21 divided by 7 is 3. 28 divided by 7 is 4. And then 18 and 16 are divisible by 2. So 18 divided by 2 is 9. 16 divided by 2 is 8. And I am definitely going to clean this one up. There's a lot going on. So the first fraction is now going to be 3/9. And then we get times 8/3, and then times 4/5. All right. So we want to simplify. I notice that I have a 3 in the top and a 3 in the bottom. So I'm going to go ahead and cancel those. So I get a 1 and a 1. So if we need to clean it up again, I have 1/9 times 8 over 1 times 4 over 5. So let's really think about this. In the numerator, factors of 8 and 4 would be obviously 8 and 4 and then 2. Well, 8s, 4s, and 2s do not go into 9s or 5s. So we are ready to multiply across. Remember, we just get 1 times 8 times 4 all over 9 times 1 times 5. Well, in the numerator, 1 times 8 is 8. 8 times 4 is 32. In the denominator, 9 times 1 is 9. And then 9 times 5 is 45. And there's your final answer. All right. Let's do one more. Okay, so for this last one with just fractions, we're going to move to mixed numbers after this. We have 30 over 21 times 15 over 45 times 16 over 24. All right. So lots that could be simplified. For me, I noticed right away that 30 and 45 have a 15 in common. So 30 divided by 15 is 2. 45 divided by 15 is 3. I also noticed that 16 and 24 have an 8 in common. So 16 divided by 8 is 2. 24 divided by 8 is 3. And then if I look at 21 and 15, I could simplify those. They both have a 3 in common. So 15 divided by 3 is 5. 21 divided by 3 is 7. Now I'm going to clean this up in case you can't see what's happening. So I have, back to the blue, I have 2/7 times 5/3 times 2/3. So in the numerator, I have 5s and 2s. 5s and 2s do not have any common factors with 7s or 3s. So we just multiply across. So I have in the numerator 2 times 5 times 2 all over 7 times 3 times 3. So in the numerator, I get 2 times 5 is 10, and then times 2. So in the numerator, I get 20. In the denominator, I get 7 times 3 times 3, where 3 times 3 is 9. Well, 7 times 9 is 63. So my final answer here would be 20/63. All right, so if we go back just kind of briefly, multiplying fractions, technically what you do is you multiply across and just make sure you get everything simplified. For me, I like to simplify first, and that just means look for all of those common factors in the numerator that could cancel with something in the denominator. Once I get everything simplified, then I multiply across. We did lots and lots of different examples. Make sure you go through these examples and work them out on your own. All right. And you can refer back to any of these to make sure you get the right answer. The key to math is like actually doing the problems. Okay. Don't just watch the video and watch how I do them. Get out paper and pencil and do the problems right along with me. All right. Now for the next part, we want to multiply mixed numbers. All right. And here is the thing that you absolutely must hear. You cannot multiply mixed numbers. Okay. Whoops. However, if you go back a few videos, we know that mixed numbers are really just another form of an improper fraction. So when you're multiplying mixed numbers, you need to know that you can't multiply mixed numbers. There's none of this like multiplying the whole numbers and then multiplying the fractions. No, 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 no. Instead, what we do is we convert all mixed numbers to improper fractions. And then follow the steps for multiplying fractions. And just so that we can make sure we all remember how to convert mixed numbers to improper fractions, let's practice. So we're going to convert mixed numbers to improper fractions. So that's in a previous video, but just in case, let's do a couple. So let's say that we have 5 7/8. Hopefully you remember that we take the denominator and we multiply it by the whole number. So I take 8 times 5, add the numerator, and then everything stays over that original denominator. All right, so I get 8 times 5 plus 7, all over 8. In the numerator, we need to multiply first, add second. So 8 times 5 is 40. 40 plus 7 is 47. So 5 7/8 is really the same as 47/8. So if we were multiplying a problem that contained 5 7/8, we could not use the 5 7/8. Instead, we would need to use its equivalent form, 47/8. Let's try one more just to make sure everybody's good. Let's say we have 12 2/3. So again, denominator times numerator, denominator times whole number, plus numerator all over original denominator. So 3 times 12 is 36. 36 plus 2 is 38. All of that over 3. So again, if a problem contained 12 2/3, we could not use the 12 2/3 for multiplication. Instead, we would need to use 38/3. All right, so let's practice. Okay, we'll start with an easy one. We'll just start with a whole number and multiply it by the fraction 5/12. So we've got the whole number 8. We want to multiply it by 5/12. What a lot of people find to be easier is to just write that whole number as a fraction. Easiest way to do that, put it over 1. All right, so I have 8 over 1 times 5 over 12. I want to look for any common factors in the top and bottom that can be divided out. For me, I notice a 4. 8 and 12 are both divisible by 4. So 8 divided by 4 is 2. 12 divided by 4 is 3. All right, if I were to clean it up, I have 2 over 1 times 5 over 3. There are no longer any common factors in the top versus the bottom, so I multiply, and I get 10/3. Now, let's talk about 10/3. I am perfectly okay with 10/3 for a problem like this. right? We discussed this in the video where we talked about mixed numbers. A lot of times it's very important to convert your improper fraction to a mixed number, especially if you're dealing with like a word problem. Word problems are the big ones. 10/3 doesn't make a whole lot of sense. Like if I said, hey, this class ate 10/3 pizzas, okay, what does that mean? But if we convert it to the mixed number and we say, hey, this class ate 3 1/3 pizzas, that makes sense. So when you have a problem like this and your answer is 10/3, 10/3 is fine. If it is a word problem, it generally makes way more sense to convert it to a mixed number. Also, if you start with mixed numbers, it makes more sense to have your final answer a mixed number. Just be consistent across the board. So 10/3 is correct. However, we could convert this to the mixed number. Now, we didn't practice this a minute ago, so let's practice it now. We take 10 and we divide it by 3. Well, how many times will 3 go into 10? 3 times. What's left over? 1. So 10/3 or 3 1/3 would be the correct answer, okay? Sometimes it's better to stop while the getting's good and just leave your answers 10/3, but keep in mind, if you start with mixed numbers, oftentimes you'll end with mixed numbers and then word problems. That's when you want those mixed number answers. Let's try another one. So let's say that we have 5 1/4, and we're going to multiply by 1 1/7. Well, remember, we cannot multiply mixed numbers. We just can't do it. So we have to convert these mixed numbers to their improper fraction format. Okay? So for 5 1/4, we take 5 times 4, we add 1. So 5 times 4 is 20. 20 plus 1 is 21. And we keep the original denominator of 4. We repeat the process for 1 1/7. I take 7 times 1, which is 7. I add 1, which is 8. I keep the original denominator. So now I can proceed with those steps for multiplying fractions, like what we did over here. All right. So I look for any factors that I could cancel top to bottom. All right. I'm drawn to the 4 and the 8 first. I know that 4 and 8 have a 4 in common. 4 divided by 4 is 1. 8 divided by 4 is 2. I also happen to know that 7 and 21 have a 7 in common. So 7 divided by 7 is 1. 21 divided by 7 is 3. All right, I can multiply across now. So 3 times 2 is 6. 1 times 1 is 1. But in this case, I don't want to leave my answer as 6/1 because it's kind of not simplified. Instead, I want to write it as just the whole number 6. All right. Hopefully this isn't too bad. Let's try 1 6/9 times 1 6/18. Now, you have options here. You could go ahead and convert to your improper fractions, start simplifying, and go on from there. Or you could go ahead and start simplifying the fractions in the mixed numbers, then convert to improper fractions, and then do the multiplying. It's up to you. For me, I kind of like the idea of simplifying my fractions now. I noticed that 6 and 9 have a 3 in common. So 6 divided by 3 is 2. 9 divided by 3 is 3. And that gives me 1 2/3. Now for the second fraction, I noticed that 6 and 8 have a 2 in common. So 6 divided by 2 is 3. Ooh, even better. 6 and 18 have what in common? They actually have 6 in common. So 6 divided by 6 is 1. Whoops. Let me get that line back in there to separate the problems. Okay, so 6 divided by 6 is 1. 18 divided by 6 is 3. All right, so I get this fraction is really 1 1/3. All right, now you didn't have to simplify first. You could have gone straight to converting to improper fractions and then doing your simplifying. I just felt like doing it right away. So now we're going to convert everything to improper fractions. So for 1 2/3, I take 3 times 1, which is 3. I add 2, which is 5. So I get 5/3. For 1 1/3, I take 3 times 1 is 3, plus 1 is 4. So I get 4/3. thirds. Remember, we're looking for common factors top to bottom. Well, factors of 4 would be 2 and 4. Factors of 5 would just be 5. None of those go into 3, so we're ready to multiply across. 5 times 4 is 20. 3 times 3 is 9. Now, we're in that same situation as what we were in the first example on this slide, where we have the improper fraction. 29ths is absolutely correct. We did, however, start with mixed numbers, so it would not be uncommon to write your final answer as a mixed number. So just to remind yourself, 9 goes into 20 2 whole times. I have 2 left over. So 29ths is 20 and 2/9. All right. Let's try maybe 2 more problems. And for these problems, we're going to have 3 mixed numbers. So let's say I have 1 and 3/7 times 1 and 5/35 times 1 and 4, no, times 4 and 10/15. So kind of similar to the last problem, 2 of these mixed numbers could actually be reduced. The fraction part could. So let's do that. For 5/35, the 5 and 35 have a 5 in common. So 5 divided by 5 is 1. 35 divided by 5 is 7. And then if I scoot over to the 10/15, 10 and 15 have a 5 in common. So 10 divided by 5 is 2. 15 divided by 5 is 3. Let's clean everything up. I get 1 and 3/7 times 1 and 1/7 times 4 and 5/3. All right. So now we can convert everything to an improper fraction. All right. So for 1 and 3/7, I take 1 times 7, add 3. So I get 10, and it goes all over the original denominator of 7. For 1 and 1/7, I get 7 times 1 is 7, plus 1 is 8, all over 7. Finally, I get 3 times 4 is 12, plus 5 is 17, all over 3. All right, so I do not have any common factors top to bottom. All right, 10 and 8 have factors of 2 and 5 and 4. 17 is prime. None of those factors go into 7 or 3. So we are ready to multiply across. You are welcome to use a calculator if you don't know what 10 times 8 times 17 is. You could also just do side work, whatever you prefer. So I'm going to use a calculator really quick. 10 times 8 times 17 is 1,360. And then I'm going to divide that by 7 times 7 times 3. So I get 147. Now, this would not be exactly easy, we'll say, to convert to a mixed number, but you could do it. All right. So I'm going to take 1360. All right, let me do a little side work over here. We're going to take 1360. We're going to divide it by 147, and I am going to cheat and use my calculator to help me. So 1,360 divided by 147, it goes in 9 whole times. 9 times 147 is 1323. And 1360 minus 1323 is 37. So over here we get 100. Whoops, no, we don't. Over here we get 9 and 37 over 147. Now, generally speaking, when you're dealing with a quiz or a test, you're not going to get numbers that are kind of nasty like this. You'll generally get stuff that's maybe a little smaller, a little easier to work with, but be prepared in case you do get numbers that are a little bit bigger like this. All right, let's do one more, and I am going to erase this side work here, just so I can do both problems on the same page. All right, let's do one more problem, and then we'll wrap this video up. I have 4 and 4/24. I'm going to multiply by 1. And let's see, 12/36. And then I'm going to multiply that by 9/15. All right. So I kind of want to do what I did in the last 2 examples, where I simplify first, then convert to improper fractions, then do my multiplying. So I notice in the first mixed number, 4 and 24 have a 4 in common. So 4 divided by 4 is 1. 24 divided by 4 is 6. 12 and 36 in the second mixed number have a 12 in common. 12 divided by 12 is 1. 36 divided by 12 is 3. Finally, 9 and 15 have a 3 in common. 9 divided by 3 is 3. 15 divided by 3 is 5. So let's clean up. We've got 4 and 1/6 times 1 and 1/3 times, times 3/5. All right. So remember, we can't multiply mixed numbers, so we have to convert them to improper fractions. So 4 and 1/6, I take 6 times 4 is 24, plus 1 is 25. So I get 25 over 6. I then get 3 times 1 is 3, plus 1 is 4, all over 3. And then don't forget I've got my 3/5. Now we can start simplifying some more. All right, so let's see. I noticed 25 and 5. They have a 5 in common. So 5 goes into itself once, into 25 5 times. I notice 6 and 3. So 3 goes into, or even better, let's do it like this. 3 and 3 reduce. So 3 goes into itself once, 3 goes into itself again once. And then 6 and 4 have a 2 in common. So 4 divided by 2 is 2. 6 divided by 2 is 3. Let's clean this up a little bit. I've got 5/3 times 2 over 1 times really just 1 over 1. I multiply across, there's nothing else common top to bottom. So I get 5 times 2 times 1, which is 10. And then I get 3 times 1 times 1, which is 3. Again, 10/3 is perfectly acceptable, but we did start with mixed numbers, so it would be normal to convert this to a mixed number. 3 will go into 10 3 times with 1 left over. And there you have it. All right. So again, just to kind of recap, multiplying fractions, you technically multiply across and simplify, but I think it's a lot easier to simplify as you go. It makes the whole process much easier. So I cancel common factors top to bottom, then I multiply across. We did tons of examples, okay? Tons and tons of examples. And remember what I told you with math is you actually have to do the problems, okay? So even though you're watching me work through the problem, work it out yourself, get a whiteboard, get scratch paper, and actually sit down and write the problems out, work them out with me. You could even write the problems down, watch the video. Once the video's over, go back, work out the problems, and then check to see if you got the right answers. It is absolutely okay to do problems multiple times, okay? Key is practice. As far as multiplying mixed numbers go, you cannot actually multiply mixed numbers, but luckily, mixed numbers can always be converted to improper fractions. So we reminded ourselves how to convert to improper fractions, and then we practiced. So you convert your mixed numbers to improper fractions, you simplify, you multiply across, and depending on your answer, if you do get an improper fraction, it kind of depends on whether or not you convert it to a mixed number. For most cases, the improper fraction is fine, okay? A lot of times, though, if you start with mixed numbers, you will see your final answer as a mixed number. So do prepare yourself for that. And also word problems. Word problems, it's very, very common to write your final answer as a mixed number. Remember, I gave the example, if this class ate 10/3 pizzas, that doesn't really make sense. But if I said, hey, this class ate 3 1/3 pizzas, that makes a lot more sense. So again, word problems, you'll generally see the mixed number. All right. So hopefully that was a decent overview of multiplying fractions and mixed numbers. The next video in the series is going to be dividing fractions and mixed numbers, and it's very similar. There's just like one extra step, but otherwise it's the same thing as multiplying. And then after that, we're going to start doing the adding and subtracting of fractions. And generally people that didn't appreciate fractions in the past, it's because of adding and subtracting. So make sure you really study and practice all the previous videos. Make sure you're really good with simplifying, converting, multiplying and dividing. And then when we get into adding and subtracting, hopefully it won't be such a shock. All right, best of luck.